Lesson 4.7, Scientific Notation. A number is written in scientific notation if it has the form c times 10 to the nth power, where c is between 1 and less than 10. So it can be like 9.999, but it cannot be 10. So it's 1 through like less than 10. And n is an integer. Standard form is the way that we normally write numbers, like 725,000 or 6 thousandths. Product form is making it into a decimal, so again this is between 1 and less than 10. And multiplying it by the place value. Scientific notation for 725,000 would be 7.25, again between 1 less than 10, times 10, it's always to a power of 10, to the 5th power. 6 thousandths, product form, would be 6 times 10 to the negative 3rd. A general rule is if it's a really big number, like 725,000, then you're going to have a positive exponent. If it is a really small number, you might want to write this down. You're going to have a negative exponent. Let's write numbers in scientific notation. We use scientific notation a lot in science when we measure very large distances or very small objects like cells or atoms. The average distance Mars is from the Sun is 141,600,000 miles. Write this number in scientific notation. Well, here's standard form. It's the way that you normally would write it. You could go through product form to get to scientific notation. However, I like to just skip product form sometimes. Otherwise, here's how you write product form. You change this number so that their decimal, which is actually at the end, is between 1 and 10. So I would put the decimal right between the 1 and the 4. So it's 1.416. And the place value is 100 million. Scientific notation uses that same 1.416, but now you count the spaces. 1, 2, 3, 4, 5, 6, 7, 8. So you have 10 to the 8th power. Again, you make sure you're counting the spaces when you move the decimal point. Part B, the diameter of a 1/4 ounce gold American Eagle coin is 22 thousandths meters. Write this number in scientific notation. So there's standard form. Again, you can go through product form, but I like to just skip right to scientific notation. It's up to you. We're going to move the decimal between the 2 and the 2. So it's 2.2. And we moved it 2 spaces. It's a small number, so it's a negative exponent. Remember, this number 2.2 needs to be between 1 less than 10. In example 2, now we're going to write it in standard form. So I'm going to give you scientific notation and your answer needs to be in standard form. So standard form is 4.1 times 10 to the 4th power. Again, you can go through product form to get to standard form, or you can just go right to standard form. I'm going to show you how I skip product form with this one. I just write down the 4.1, and now I know I'm moving, and this is the number of spaces that I'm moving, 4 spaces. Do I want the number to be bigger or smaller? It's positive, so I want bigger, and that means I'm going to go right. So 1, 2, 3, 4 for my decimal point. These spaces that don't have a number, I put zeros. So I have 41,000. You can see that's the answer. Let me show you for part B. Again, I write down 7.23. I know I'm moving 6 spaces, and the negative means I'm moving left because I want it small. So 1, 2, 3, 4, 5, 6. And after the decimal, or before the decimal point, I actually put a 0 too. And you can see that's what I have as the answer. Please pause the video and try 1 through 4. If you want to go through product form, you may, but you don't need to. Number 1, decimal point's going to go between the 3 and the 0. Oops. Let me write it down first. You don't need any other zeros that are at the end. What you do need to do is you need to count the spaces, because it's 3.05 times 10 to the, well, we started at the end, 1, 2, 3, 4, 5, 6, 7, 8, 9th power. For number 2, put the decimal between the 8 and the 2, because that's between 1 and 10. And we moved it 1, 2, 3, 4, 5. And it's negative because it's a small number. For number 3, I write down the decimal point, and the 7 tells me how many spaces to move. It's positive, so I'm making it bigger. So I'm going to make it go right. 1, 2, 3, 4, 5, 6, 7. Add the zeros. Sometimes I do like to rewrite it just so I don't have those space markings. Number 4, 9.2. We're moving negative 4 left. 1, 2, 3, 4. Add those zeros, add 1 before. There's your answer. We can order numbers using scientific notation as well. So let's order these 3 numbers from least to greatest. Let's write each number in scientific notation. Well, 2 of them are already done. We just need to change the 520,000. That's going to be 5.2 times 1, 2, 3, 4, 5. So now let's look at the powers. We have a 5, a 5, and a 4. Because 4 is less than 5, we know that the 7.5 times 10 to the 4th power is going to be the lowest. Now, when we order, so this is going to be the lowest. That's what they're saying here. We know that we order with the same power. We look at the decimal points, and you can see that 5.2 is less than 5.3. Again, they both had a 5, so now we need to look at the decimal points. That means that 5.2 times 10 to the 5th is going to be less than 5.3. So 7.5 was the first one, 5.2 is the second, and the third is 5.3 scientific notations. And again, write the original numbers. So we started with the 520,000. Put that in your answer. Just try number 5. Change this to scientific notation. 2.3 times 10 to the 1, 2, 3, 4. We know 3 is smaller, so we're going to have 3.4 times 10 to the 3rd first. We have 2 4s, 2.2 and 2.3. So we have 2.2 next, times 10 to the 4th, and then 2.3 times 10 to the 4th. Oops, and again, see my mistake? Make sure you're writing it using the original numbers. We can multiply numbers in scientific notation as well. The volume of 1 mole of oxygen atoms is about 1.736 times 10 to the negative 5th cubic meters. Find the volume of 1.5 times 10 to the 4th moles of oxygen atoms. What they're asking us to do here is multiply the 2 numbers together. So let's do that. In order to do that, what we're going to do is we're going to multiply the decimals together. We're going to move them next to each other. That's what they do here. Okay, this is the commutative property and associative property, telling us because we're multiplying all the numbers, we can move them in any order we want. Now we're going to take the powers of 10, and we're also going to multiply them and move them together. So 1.736 times 1.5, and you can use a calculator, is 2.604. We have product of powers. Let me just bring that down. Product of powers tells us same base, so we can just add the exponents. -5 plus 4. -5 plus 4 is 10 to the negative first power. So your answer is 2.604 times 10 to the negative first power. Please pause the video and try numbers 7 and 8. For number 7, we're going to multiply the two numbers together, the decimal point or the regular numbers, you get 5, times, add the exponents, 10 to the 8th power. For number 8, 1.5 times 4, and again, you can see that I'm not moving the numbers. If you understand that you just multiply the two decimal points and then add the exponents of the powers, then you don't need to move anything. There's your answer.